Yeah, good afternoon, everyone. On behalf of our organization, I'll be presenting here about lean new product development. A little background about our organization. We are the Shibaura Machine Group. It is based at Japan, and we have 6 locations all over in the world. We having the 6 manufacturing units. Over 85,000 machines installed all over the world. And the presence is in 50 plus countries. Thank you. Coming back to the Shibaura machine in India, we were part of earlier Larsen & Toubro group. We were present in India since 1990. Our journey starts with L&T till 2012. Then it was taken over by then Toshiba machine. That is now rebranded as Shibaura machine in 2020. So about the products what we manufacture injection molding machines, which is with different tonnage ranges. So these are the 5 different products what we manufacture with the toggle type clamping system from 60 ton to 1300 ton. Then a ramp type hydraulic machine. We are also making a new wider platen toggle system. Then completely all electric toggle machine. Then a hybrid machine, which is a combination of hydraulic and electric machine. So I'll be presenting about the product developed about this wider toggle version, that is from 80 ton to 2000 ton, which was done recently. So just a little background about the product. This is basically an injection molding machine, wherein the left hand side is the clamping unit of the machine. So wherein the plastic part is molded into it. The orange color part is the plastic part which is coming out from the machine. Typically the cycle time will be around 20 seconds around. So depends on the weight of the part, the configuration on the injection side will be given. So there is always a possibility that the injection side and the clamping side cannot be of the same size in a given machine. So there is a possibility that we have to have the modularity. So we have to have the combination of clamping unit size and injection unit size. So if you see here, the product what we developed is having the 6 sizes in the clamping side, similarly 6 sizes in the injection side, and these are modularly connected by having 3 sizes with each other. So this was the time plan given earlier for this series. This is 6 sizes we have to develop with the deadline of completing it in 24-25 December. When you see this, the original time plan, there was a scope change introduced in the December 2023-24. This has a major change in the specification itself, which means instead of having the standard platen, they have to have a wider platen. Already we are in the half stage of the design, so we have to completely stop it and we have to go with a new one. This is the new plan. We don't want to delay further, and all the 6 has to be taken simultaneously and completed with the original series completion date. So now coming back to our history of development, what we have done so far. If you see, basically our time to market is around 20 months. Now the target given is 12 months. And the rate of development, what we have done is around 2 products per year. not more than that. Now, in the latest scenario is 6 products has to be given in 1 year. Apart from this request, there is also a normal, any new product have a normal objective, like reducing the cost by at least 10% by doing so many activities. Apart from, it has to run given as a speed machine. Instead of 20 seconds, it has to be improved by at least 15%. So the machine has to be faster, at the same time it has to be cheaper, and moreover it has to be done in 1 year for 6 products. So now how we will approach? So typically the process flow for product development is given in this left side. So this is a linear flow. Normally we take the development with a detailed design, then do all the analysis, then we build the prototype, we test it, then put for the product approval, send it for field validation, take the feedback at every stage and consolidate the feedback and put in the product launch before commercialization. So this is the process we follow. This process will take 16 months from design to approval, from product to product approval. The validation and product launch will be further 6 more months or so. So we just want to go with a lean approach. A lean approach, we want to reduce the time to from 16 months to 12 months. So we thought of bringing 3 concepts here. That is, one is the concurrent engineering approach, by having the parallel activities running between the departments to reduce the time for development. Then during prototype testing, we have to put in the Kanban system to reduce the time there, whatever is possible. Then instead of making the full product, we want to go with the minimum viable product and put it into the market, test it. Then during the feedback, we will add the options and give it as a full product during the launch. So these are the 3 approaches we have taken in this project. So the basic principles what we applied is given here. So the work style is that many activities were parallel earlier, that we have to limit to the minimum WIP activities. The decision has to be taken then and there whenever there is a problem or there is a stoppage in the development. Then feedback has to be taken immediately, and that has to be done, the corrective action to be done then and there. Then there should not be any this delay in the communication. So we have to keep the continuous cross-functional information flow. So this is the breakup of the time for 16 months. So if you see on the left side, the procurement takes 16 months for developing the pattern and getting the items ready. In the meantime, the design will take care of the cladding development, options development, all those things will happen. So in the concurrent approach, what we followed is that we want to reduce that 6 months procurement to 3 months. So 3 months includes pattern development and getting the castings and to be manufactured in-house. So rather than reducing the procurement alone, we have to have the design also to be compressed within 3 months. So we have to have many parallel activities done. So, and we have moved that options design, which is given in the left side, is now moved to the area after the prototype development, because we want to implement this MVP also. So we are able to see that there is a reduction in 12 months. Coming to the MVP approach, we taken this product only with the basic configuration which is used to run this machine. The idea of this product is that it has to be compete against the low-cost Chinese manufacturers' products. So wherein the number of options are restricted, whereas in the Indian products, the options are very much huge. So we want to go with this options design later, So what we have done is that we have taken the machine, basic machine alone, the standard machine that has been taken up for the design, build the prototype and taken it for the product approval. The options are in such a way that most of the options, that is 75% to 80% of the options need not be tested. It is a one aesthetic kind of design, or it will be it is not a functional requirement. So what we have done is that we removed those optional features and we have taken up without the option features and put it into the customer place. So some example what I have given here in this is that if you see that the top surface which is circled in the right side is not taken initially, which is an aesthetic requirement. Similarly, the hopper which is given on the right side, for some of the customers, they will put their own auxiliary unit over there, whereas we will, as a standard machine, we were giving the hoppers initially. So these are some of the features which have been removed. So because of that, the time for designing these parts are completely not there in the initial product development. So by this, we were able to see that we reduced the design time by 6 weeks. We also taken the Kanban implementation for the product testing, new product testing. Typically, the time taken for testing this machine at in-house will be around 6 weeks. Here, the 6 weeks has to be reduced to 4 weeks to make this all 6 products completely built within the schedule. So what we have done is that because it is not a standardized activity, the prototype testing is one of a kind, and which we don't have the common SOP procedure or something like that. So we thought of taking that into SOP and create a display system so that what is actually happening to improve the predictability and how to make the testing faster. So what we have done is that we have taken the Kanban board. A machine needs to be tested for 30 different tests, and it has to be cleared all the 30 tests before taking it to the product approval. So these 30 tests are taken, and all the schedules are prepared for all the 30 tests for the 6 machines. And this has been identified in the different categories like to do and what has been already completed, what is in WIP, and where we are lagging. So all those things are displayed, and these results are being displayed not only in the machine developed area, it is also displayed in the R&D room, so that at the end of every day or continuously over the day, we were able to see what is actually happening in the machine and because of what reasons the machine is stopping for moving to the next test. So because of that, we were able to see that there was a reduction in the time of 2 weeks. Now coming to the results, we were able to see that this machine has been, we targeted for the 15% reduction in the cycle time. We were able to achieve 4 machines with that reduced cycle time, but 2 with a marginal achievement. Then part commonization also we targeted for 55% with respect to the existing products. We have come close to 55% in 2 products, and remaining 3 we have not. Similarly, footprint reduction, parts reduction, in some of the products we have achieved, in some we have not achieved. Coming to the oil consumption, we targeted for 15% and closely we achieved in all the products. Raw material usage also we targeted for 15% and we achieved in 3 products. And the cost, what we have targeted is 10% in 4 products and 8% in 2 products. We achieved the cost reduction target in 2 products. Coming to the timeline, this is typically, like any timeline, we planned for 1 year for all 6 products development. Like typically any plan, we have always the delay. And that delay occurred during the procurement stage, like what I have explained in that. But we were able to see that we are on schedule for the 2 products. And 2 products were being delayed by a month and 2 products delayed by 2 months. So the key learning is that we were able to see that the waiting time is been reduced a lot during the new product development, and the decisions were taken very faster, and we were able to see that the systematic approach can be brought in the new product development also. So the way forward is that we want to extend this concurrent engineering to the suppliers also. We were not able to extend this concurrent engineering to the supplier end because they were at a different location. Even though we have the online and web meeting and other things, it is not possible effectively. We have not done. We have to think of doing it. And we want to extend this to the manufacturing and assembly for the new product development as well. So I request any questions you have.
Just now you said that vendors are also to be taken into conference for this concurrent.
Yes.
Actually, I wanted to ask the same thing because earlier what benefits you have shown.
Yes.
Whether vendors were part of it or they were not part of it?
No, our vendor development team were part of it.
Okay.
And vendor development team were coordinating with them.
Okay.
And vendors are not directly taken into confidence for this. So here we have to broaden this. See, the problem is here is that we want to develop this casting using 3 vendors. And 3 are competitors to each other. So there are some more improvement is required here. So that is why.
But that casting was bought in-house, no? Finally.
Sorry?
That casting was bought in-house. In the sense you started manufacturing in-house.
No. We are not. Castings are not made in-house.
Okay.
Only machining is done in-house.
Okay. Thank you.
Yeah. Frankly, when you look at the NPD process that you showcased, I think what do you think is the most significant part of your learning along this journey? That didn't come out very clearly. Is there anything unique which you think? I mean, it's a great journey. Don't mistake me. It's a great journey from your own internal self. But from a perspective of what others can learn from you, do you think something comes out that way? Something which you think others can benefit?
I want to tell this way. See, normally for a continuous manufacturing process, lean is expected. But for one kind of ununique, unstandardized process like new product development, lean can also be applied when the number of products to be developed is more. See here, even though we are developing 6 models in a year, something around 80 to 90% of the activity is common between these 2. Even though the size and the different modularity varies, there is a possibility that these processes can be standardized in such a way that this can be applied here. So that is the key learning we have taken it.
But does this shrinking of your lead time for new product development, is it a competitive differentiator? Does it help you get more orders if you say, I will develop this thing within so and so time?
Yes.
In that case, can you go back to slide number 17? Slide number 17, please.
It's not displayed.
Okay, that Gantt chart.
Yeah.
That Gantt chart which you showed, there was a big, long band, which was not concur. Yeah, so there's a big long band which almost straddles about 2 or 3 months. What is that band on top?
Which one? Sorry?
After the, in the 4th column, it starts. It goes on to the 5th, 6th, and 7th column. What is that entire thing? If I look from top, the 1st, 2nd, 3rd, 4th, the 5th one.
That is a clamping unit design. Clamping unit design.
So that is the thing which really kind of takes away a lot of your time.
Yes.
And how many months is that?
That is 3.5 months.
So is that a subject for reduction?
Possibility is there.
No,
Possibility
as
is
of
there.
now, shouldn't that be one of the priority ones? Because things waiting for it to happen, obviously.
Yes,
Because if you don't design, you can't.
Yes,
So
possibility is there, but initially, before this project, it was 6 months. That we have reduced to 3.5 months.
Okay.
This is an iterative process. and we doesn't know when we will get the exact result.
Okay.
So that is why we were not able to reduce beyond this.
Those are the things you need to work for.
Yeah.
Can I request you to not ring the bell so many times? Once is enough. Yep. Once is enough. Yeah. Don't ring it 5 times. I think it's a good learning. But I think the critical path remains largely, you have reduced from 6 to 3. I think it's a great job you have done.
Yeah.
Can anything be done in parallel over here while it is being designed?
See,
along the critical path.
Agreed. This is for all the 6 products together. There is a separate Gantt chart available for all the 6 products. So if you see the clamping unit design of 3.5 months, for example, what you have asked for, it is for the 6 products. Earlier it was 6 months for 1 product. So like that, many things are done parallel.
Sure.
See, I have not mentioned here, there is also, we were able to manage the resource what is required, but there is another task which I have not spoken about is the human resource management, which we have taken up with the confidence of the management, and many internal transfers has been done to develop this product.
Sure. Okay. Yeah. Thank you so much. Yeah. Thank you so much. I appreciate your answers. Thank you.
Do we have any questions from the audience for Shibaura machine? Yeah, there's a hand going up there.
When you look at this product, lean product development, as you turn, one is you had to do so many things concurrently, right, to reduce the time.
Yes.
So our experience has also been when you try to, especially the DVP, the validation part you are trying to do, and I don't think in a traditional method you would have done a complete product and the final product would have gone through a validation. But now you are trying to do in between and the final product would not go through it, correct?
Yes.
You are trying to skip. So always there is a chances of a surprise when we do with the final product. So how are you really addressing this? Because this has been an experience.
Correct.
Every time that when we see traditionally why it went through is the reason was it was required. But now with the market requirement that you have to cut down, we cut down it. But then we get into a problem and then the backlash is very severe sometimes. You know, you may lose your market share, branding, everything gets into a trouble when we do that. How are you going to accommodate when you bring in a lean concept or a lean NPD development but not lose any of the final product in terms of its reliability?
Yes. See, the options I told you, 80% of the option doesn't require testing. That is prototype testing. So we reviewed those options and whether this can be taken up in the development later stage or not. So that we have taken the confidence of not only our marketing team, we also taken the confidence of our service team. And those options only have been removed initially. And that has been bought up as, options even if you build also, it is not a possibility to test during the prototype manufacturing because those options are not inbuilt in the prototype machine itself. But we will do the design 100% complete upfront. So we see that it doesn't add the value. So that is why we have taken up in the later phase. But I feel that there may be chances that some surprises may be there. Probably so far, but we have launched this product last year and since close to 9 months, we have not seen any issues so far. Yeah, thank you.